Right. We're looking at the reactions. We're looking at the reactions of carbonyl compounds with hydrogen cyanide and sodium hydrogen sulfide. But in this case, you're going to look at the reactions with the derivatives of ammonia. With the derivatives of ammonia. Of course, these derivatives of ammonia react with carbonyl compounds, either in presence of acidic media or in neutral solutions. And the products form the crystalline solids with a characteristic color. And that is to say they form precipitates. Okay. So the reaction is very fast in presence of an acid than in neutral medium. But let's look at reaction with the hydroxylamine. This is reaction C. At one reaction with hydroxylamine. And this is NH2 OH, hydroxylamine. Reaction with the hydroxylamine. Okay. These reactions generally with the derivatives of ammonia can be called condensation reactions. And here we've said that carbonyl compounds react with compounds containing the amino group. Okay, when I say amino group, this is the NH2 group. Form compounds containing the imine group. We have what we call the imine group. So what we form is called the imine. We form the imine group compounds. They have the imine group CN. Okay, so compounds react with the carbonyl compounds react with the compounds containing the amino group to form the imine group. Of course, with elimination of water. Okay, so when the reaction with the reaction with hydroxylamine, we form what we call oximes. We form the oximes. We form the oximes. So for example, if you have CH3, CO, then CH, reacting with NH2OH in presence of any acid, in presence of an acid. This is ethanol. So when ethanol reacts, actually this is just CH3, COH. This is ethanol. When it reacts with hydroxylamine in presence of an acid, we form the ethanol oxime. We form the ethanol oxime, which is CH3, CH, then NOH. The water eliminated, we can add it here. All right, so you're going to look at the mechanism for this reaction. Let's look at the mechanism for this reaction. With the mechanism, of course, we shall first have CH3, C, H. Now, we need to know that the characteristic reactant here is the acid first, then this one will come in later. So what happens is we shall have hydrogen here. So the lone pairs of electrons. So hydrogen is being picked, so we shall form CH3, C, OH. Then H. Then there we bring the hydroxylamine. Okay, so now hydroxylamine, NH2, OH. The lone pairs on nitrogen will come over the carbon, while one bond will break off, forming CH3, CH. When one bond has been broken, remember bond, what comes with is electrons. So this is positive, electrons will neutralize the positive, so we shall have just OH. But with that compound attached, NH2 or H, but with a positive. So the following step is the hydrogen shift. There is hydrogen shift. Now, when hydrogen shift takes place, we shall form CH3, C, or H2, because hydrogen has been shifted, but because an hydrogen has come, we shall have a plus here, then H. Then now here, hydrogen shifted from this compound, so we shall have one H here. So it will be, and the plus will go in that case. So we shall have NH or H, NH or H. Now what takes place is that the lone pair of electrons on nitrogen come over here, form a double bond, then the water this arrow is taking the water off. So it means that we have lost water. When we lose water, we shall form CH3, right? CH3, CH, but here is a double bond because the bond came here. So we shall have a double bond. N, because the electron is left nitrogen, so it is positively charged. H or H. This is followed by the loss of hydrogen ion in order to stabilize this compound. So we have loss of hydrogen, and when hydrogen is lost, we shall form CH3, C, H, I can put it down here. Then double bond, NOH. This is my product. So we said that we lose a water molecule. We form imines with water molecule loss. This is an imine group. So that is how the reaction takes place. So in this video, let's also look at what if the reaction takes place in absence of an acid? What if we don't have an acid? Of course, the oximes formed are crystalline solids. You need to know that. Yeah, so let's look at what if it takes place in absence of an acid or in a neutral medium. Wow, in neutral medium, we shall have ethanol, then H plus NH2 OH. So still here, only that the reaction is slow. CH3, CH, NOH plus water. If you're not sure of the product, first write the mechanism. So now in this mechanism, we don't have that press, or we don't have that step where the oxygen goes to hydrogen. No, we do not have an electrophilic attack first. So we shall have CH3, C, this is plus, and this is minus. You bring your hydroxylamine, NH2OH. You come on carbon as the oxygen goes. So that is how where we start from now. So we shall form CH3, C, but now oxygen, the moment it gains electrons, then it has to have a negative charge. Then, of course, this H, I can put it here. Then I can have N, it gained a plus, remember. We have H, this is my NH2. Let me write it like this, NH2, then OH. So what happens is that this oxygen, I've indicated the hydrogen shift like this, then this bond here will stabilize the nitrogen so that we form CH3, C, H. So now we'll have OH. Then I'll have NH because hydrogen shift took place. So one hydrogen went, so we have NH only. Then OH. So what takes place is that the lone pairs of nitrogen here will come create a double bond as the OH goes. As the OH goes. So this one will lead to the formation of CH3, then CH, then a double bond, Then N, after losing electrons, became positively charged. Then H, then OH. Right, then the OH that got lost, this OH, is now coming to come to hydrogen as high as this bond on hydrogen stabilizes the nitrogen to form our final compound as CH3, CH double bond, NOH, then plus the water. Why water? Because this bond picked hydrogen to make this one water. So that is it in absence of an acid. Let me see if I can do another example here. Let me see if I can do another example here. I can do another example. So what we formed above is called ethanol oxime. This is ethanol oxime. We form oximes with phenyl with hydroxylamine. So if we have like this, NH2OH in presence of any acid, we shall form phenyl ethanol oxime. Shall form phenyl ethanol oxime. If you are not sure, first outline the mechanism. So we shall form phenyl ethanol oxime. The mechanism here will start by having we have CH3. So we shall first have the electrophile hydrogen. So this one will lead to the formation of this COH plus, then CH3. Then at this point, you bring your hydroxylamine. So we shall have NH2 OH. Lone pairs on nitrogen will come here as this bond breaks. So we shall form C, then CH3. Since a bond broke, we shall have OH. Shall have just OH, but then the nitrogen is going to become positive. Signs mean a lot. The moment you forget a sign here, the whole mechanism gets wrong. So OH. So at this point that we shall have hydrogen shift. And hydrogen will shift from this to OH, meaning that here at O, we shall have a positive because electrons will have shifted there. So we shall have COH2 plus, then CH3, no. Yeah, CH3. Then nitrogen, since it has lost, it is going to become NHOH. Now, the lone pairs on nitrogen, or one can put them here, will come here as water molecule goes off. So we are losing water at this point. Losing water will get you from CH3 NHOH, but with a plus. Then by losing hydrogen, we lose hydrogen to just stabilize this compound. So we shall form phenylethanol oxime, which is C. Can write CH3 here. A double bond here, we have a double bond because after the double bond got created here. So we have a double bond. So allow me say double bond NOH because one hydrogen has been lost. So that is what we form. Now let's go to the reaction with hydrazines. And we shall begin with hydrazine itself. Part 2. With hydrazine. Hydrazine is NH2, NH2. Now, we form hydrazones here. When we have hydrazine, we form hydrazones. And since these hydrazones have got the amino group, they may react further with the carbonyl compound to form azine. Okay, so we form hydrazones, but if not controlled, the reaction can go further to form azines. Okay, so for example, let me show you how hydrazines come into play. For example, if we have hydrazines and phenylhydrazine. So let's begin with the just hydrazine. And another thing, you need to know that since the hydrazine has got 2 amino groups, it may react with the 2 moles of a carbonyl compound. Okay, it may. So, e.g., if you have like ethanol, N plus NH2, NH2 in presence of an acid, we form hydrazones. So let me first outline for your mechanism and you see. These mechanisms need a lot of care when you're handling them. So we have CH3, C, double bond O, H. So first bring an acid. We shall form CH3, OH2, then with the H. Then now you bring your hydrazine, NH2, NH2. So this one will lead to the formation of CH3, C. I can bring H here. Then, of course, this one will go. So you have OH. Then I'll bring nitrogen, the one which has been involved. Then H2, I can write H down, another H down here, rather up, then I have another H2. So hydrogen shift will come in a way that this oxygen here will pick the hydrogen as this bond stabilizes the nitrogen, right? So that is how one can show a hydrogen shift. So here you form CH3, C, OH2, then H, then N, H, because one hydrogen shifted. So then we shall have NH2, shall have NH2. So in this case, the lone pairs on nitrogen will form a bond here as water goes. So we've lost water in this case. So we shall have CH3, C, H, double bond, N, because it lost electrons with a plus now, then H, then NH2, plus the water that was lost. So in this case, by losing hydrogen, we shall form our final product, CH3, CH, double bond N, because hydrogen has been lost, has stabilized this. So we shall have NH2 as our final product. So we have CH3, CH, double bond N, NH2. So that is what we call an hydrazone. So yes, then before we look at how phenyl hydrazines react, let's also look at how benzaldehyde reacts with hydrazine. How benzaldehyde reacts with hydrazine. So benzaldehyde reacts with hydrazine, NH2, NH2. In presence of an acid, form benzaldehyde hydrazone. Forms benzaldehyde hydrazone. Plus water. Mechanism. We shall have shall have benzaldehyde. Let these lone pairs be this side near oxygen, not that far. So we shall form, first one we shall form. Mind you, arrows don't make waves like this. So we shall form C or H with a plus, then H. Then now from here, we bring our hydrazine, NH2, NH2. Leading to the formation of CH. Of course, as you bring the hydrazine, this one will go. So we shall have OH, then NH2, NH2, but with a plus. Then at this point, you can shift hydrogen. You can show hydrogen shift like this, or otherwise showed it in the previous example. So we shall have CH. We have shifted hydrogen, so here we shall have OH2. Now, since hydrogen left this one, it has become stable, so it is NH, NH2. Then now, the step would be the lone pair of nitrogen creating a bond here as the water goes off. So when we lose water, we shall form CH, but here is a double bond because it has been created. So we have a double bond, or no, N, but with a plus because it lost electrons. So N, then H, then NH2. Now, by losing hydrogen in this, loss of hydrogen will lead to the formation of hydrazone. As simple as that. Now, we have said that since the hydrazones also have the amino group, okay, they may react further with the carbonyl compound to form azines. Okay. In other words, should mean that if I'm to show the formation of azine, that is why you have a benzaldehyde reacting with the hydrazone formed, reacting with the hydrazone in place of an acid, form azine. C, H, double bond, N, N, then double bond CH, the ring. Yeah, so this is what you call Azim. Azim. So interestingly, that is what we form. One may need to know the mechanism of formation of Azim. Yes, let me show it. The mechanism there. So we shall have benzaldehyde. It will first react with an acid, form this ion. Then now at this point, you bring your hydrazone that you formed. Lone pairs on this nitrogen of NH2 will come as this one goes. So we shall form C, H, or H, NH2 has become a plus because it has lost electrons. Then we shall have N double bond CH, then that compound. Right then here, we have what you call the hydrogen shift. So when hydrogen shifts, we shall have OH2 there. So we shall have C, OH2 plus, H, NHN, double bond, C, H. Then at this point, here we shall have the lone pairs of nitrogen. Making a double bond here as the water is lost. So we shall lose water. As you lose water, you form C, H, double bond because a bond created here, double bond, N with a plus now, then H, then N, double bond, C, H, then a ring. Now from here, we lose hydrogen in order to stabilize the nitrogen. So we shall lose the hydrogen. Which hydrogen is this one? So we shall end up forming our Azim as CH, double bond N, then N, double bond C, H, and that is what we call the Azim. This is what we call the Azim. Azim. Let's look at how cyclohexanone reacts with the hydrazine also. Cyclohexanone reacting with hydrazine. So if we have this, we form cyclohexanone hydrazone. We form cyclohexanone hydrazone. One can write it like this. I've said this is cyclohexanone hydrazone. So the mechanism to this reaction to begin with the hydrogen, then we shall have O plus. Then now here we bring our NH2, NH2. So the lone pairs will come on carbon as the oxygen is stabilized. So it means that here we have H here, which was gained. So we shall have some students forget and now start putting rings, which is wrong. So we shall have OH and NH with a plus, then NH2. We shift hydrogen. When hydrogen is shifted, you'll have OH2 here with a plus, then NH, because hydrogen was shifted, then NH2. So the lone pairs on nitrogen will create a double bond here as water goes. So here we shall have loss of water Okay, and as we lose water, we shall form basically, because this is now a double bond, so we shall have a double bond here, NH, NH2, but here electrons were lost, so we have a plus. So in this case, we shall lose hydrogen. And when we lose hydrogen, we shall form NH2, which is cyclohexanone hydrazine. So we need to note that both the cyclohexanones, both hydrazones and azines are crystalline solids. So this video has made us understand the reactions of carbonyl compounds with the hydroxylamine and hydrazine. So in our next lesson, we are going to look at the reactions of carbonyl compounds with phenyl hydrazines and Bladdy's reagent, 2,4-dinitrophenyl hydrazine. Okay. Then we are also going to cover how they react with semicarbazide. So, yeah, we're going to look at how they react with semicarbazide. So, let's catch up in the next video as we cover the reactions with phenyl hydrazines and Bladdy's reagent.